Hi everyone, I'm Tim Wolf from the Wolf Circle. In this video, I'll introduce the three major kinematic equations. All of the equations describe uniform motion and use the same variables, but each equation is rearranged so that it's missing one variable, and thus is specialized for solving certain problems based on what information is given and what you're trying to solve for. The first equation is missing final velocity, the second, displacement, and the third, time. There's also an equation that's missing acceleration, but is not as commonly used and will not be discussed in this tutorial. Let's begin with the first equation. You use this equation when you are not given or solving for final velocity. Here's an example. A car traveled with an initial velocity of 30 meters per second and an acceleration of negative 3 meters per second squared for a time of 5 seconds. How far did the car travel? If we substitute the values into the equation for initial velocity, time, and acceleration, then we can solve for displacement. This equation will give us 112.5 meters, and thus the car during these 5 seconds traveled 112.5 meters, given these conditions. The second equation is actually quite simple, where the final velocity equals the initial velocity plus the product of acceleration and time. This time we are solving a very similar example, except instead of solving for the car's displacement, then we're solving for its final velocity. Since the other equation doesn't include final velocity, then we have to use this equation. If we substitute the values into this equation for velocity and acceleration and time, then we get a final velocity of 0 meters per second. Thus, in those 10 seconds, the car came to a complete stop. Finally, the last equation is missing time. Let's do a more interesting example. This is a very common scenario for me. So I toss the tennis ball directly upward with an initial velocity of 5 meters per second. How far will the tennis ball have traveled when it reaches its peak displacement? Since both of my hands are full, then I can't measure the time it takes for the ball to reach its peak, but I did measure the initial velocity. And the final velocity, we can say, is 0 meters per second, because when it reaches its peak, it's no longer moving. And the acceleration of gravity is a constant 9.8, so we can use this equation to solve for the displacement. But first, we have to rearrange the equation so we're actually solving for displacement. Then we can substitute the values in for final velocity of 0, initial velocity of 5 meters per second, and put that over 2 times acceleration of 9.8, and we get an answer of 1.28 meters. That's all for this video. Thank you so much for watching, and I will see you next time.